In this question, we're told that a runner is running along a straight horizontal road. He starts from rest at point A and accelerates uniformly for 6 seconds, reaching a top speed of 7 meters per second. After that, we're told the speed is maintained for t seconds. Finally, he decelerates, coming to a stop at point B. Part A of the question asks for us to sketch the time graph to show the motion of the runner from A to B. So I'm going to sketch a velocity time graph to show what's happened. So initially we're told that we're accelerating uniformly for 6 seconds. So that's from until a speed of 7 meters per second. So that's the positive gradient, that positive diagonal line. I'm going to mark on the 6 seconds on the time axis and 7 meters per second on the velocity axis. We're then told that this speed is maintained for t seconds. So here's the horizontal line representing that over time the velocity stayed the same. And this period of time, this interval of time is unknown, but we're going to refer to it as t. Okay, so I can label both down here, and I'm actually going to do it at the top just out of habit. I know this is going to be useful later on. Finally, we're told that the runner then decelerates uniformly, coming to a stop at point B. So decelerating uniformly, I know that that's going to be a negative grade going all the way down to a velocity of 0, since we're told that they come to a stop. So this will be the sketch. The mark schemes are looking for two things specifically. Firstly, the shape, to show that you're accelerating, you have a constant speed, then you're decelerating. So positive gradient, horizontal line, negative gradient. That alone is going to be worth a mark. Second, we're going to get a mark for labeling on the axes. So the 6 and the 7, definitely we should get, and just representing the t somewhere in this diagram. Okay, in part B, we're now told the distance AB, so the distance of the entire journey, is 1,400 meters. And we're also told that the runner took 3.5 minutes to travel from A to B. So actually 3.5 minutes is 210 seconds. We can add that to the diagram, and that will be useful now when we're trying to determine that unknown value of t. We've been given the distance, and we know that the distance on a velocity time graph is going to be represented by the area. So the distance is going to equal the area. The distance we know is 1,400, and we're just going to look at this velocity time graph like a trapezium. So I've got half times, this is going to be the sum of the parallel sides. So the top parallel side is t, and the bottom parallel side is 210. So half the sum of the parallel sides multiplied by the perpendicular distance between those parallel sides. So multiplied by 7. To solve and simplify, I'm going to deal with the 7.5 first. I know I can divide by 7 in my head, and that gets me 200, and then multiplying by 2 gets me 400. So 400 is t plus 210, which easily lets us know that t is 190. T is 190 seconds.